Okay guys, so welcome dito sa ating YouTube channel. Ito na yung lesson 15 sa ating Advanced Calculus 1. So this is all about continuation lang din naman ng sequence pero medyo mas malalim na siya. Okay, so this is all about the monotone convergence theorem. So actually na-prove ko na siya last time. Hindi ko lang siya napangalanan na monotone convergence theorem. Pero I think mas maganda bigyan ko siya ng specific video about sa monotone convergence theorem. Okay, so what is the monotone convergence theorem? So a monotone sequence of real numbers is convergent if and only if it is bounded. Ayun lang simple. So a monotone sequence of real number is convergent if and only if it is bounded. So nasabi naman yan. And further, if capital X is a sequence of x sub n is a bounded increasing sequence, then the limit of x sub n is equal lang sa supremum of x sub n as if n is an element of natural number. Also, or likewise, if y is equal to y sub n and y sub n is a bounded decreasing sequence, then the limit of y sub n is equal to the infimum of y sub n such that n is an element of natural number. Okay, so tandaan lang yan. Yan yung ating application, yung ating monotone convergence theorem. Okay, so note that the MCT or yung ating monotone convergence theorem establishes the existence of the limit of a bounded monotone sequence. Yun lang simple. So kung alam mo siya yung bounded monotone sequence, so pwede na gamitin eh. So by monotone convergence theorem, automatic pwede mo siyang sabihin na siya ay convergent. Okay, so ito lang gagawin mo. Kailangan ma-prove mo na siya ay bounded increasing sequence. So kung kailangan mapakita mo yon, then pag alam mo na siyang bounded increasing sequence, pwede mo nang gamitin to. Then the limit of x sub n is equal lang sa supremum nung the set ng x sub n such that n is an element of natural number. Yan, kasama yung letter B. Okay, so ulat sa example para mas maintindihan mo paano nga ba natin gagamitin ito monotone convergence theorem. Okay, so for number 1, the limit of the sequence of 1 over square root of n. So meaning pag nilagyan ko ng parenthesis, meaning yan yung mismong sequence natin. Okay, yung sequence natin is 1 over square root of n. So ganyan yung mismong sequence. So yung limit daw ng sequence na yan is equal to 0. So let us try paano nga ba yun i-prove. Okay, so hindi ako gagamit ng natural ko. Actually, pwede rin gamitin dating ginagawa natin eh. So, without using monotone convergence theorem, kung paano natin pinoprove dati, pwede nyo gawin yun. Pero for the meantime, hindi natin gagamitin yung way na yun. So, in this case, ito gagawin natin. Ito yung proof. Okay? So, aware ka na yun yung sequence. Okay? So, ngayon yung sequence is sequence of real numbers. So, kung napansin mo, so, para siyang mga number, sequence ng number na kung saan may recursive formula. So, yun nga yung sequence niya. So, yung recursive formula na yun, so may mga generate siya na term. Tama? Yung mga generate na term is parang mga element din. Okay? So, kung ilalagay natin siya into set, so, itong gagawin ko. I-represent natin yung sequence into set. Okay? So, let natin. So, ulit sa case na to, let natin na C. So, let S to be the set containing 1 over square root of n, okay, such that n is an element of natural number. Okay, mag-start tayo sa natural number kasi 1 yung pinakamababa niyan eh, bawal naman sa 0 kasi mag-undefined. Okay, so ulitin ka lang, sequence siya. Okay, so ginawa ko lang, inilet ko lang muna siya na set S, such that yung set S is yung representation ng 1 over square root of n, okay, such that yung n element of natural number. So kung napapansin mo, yan ay set na. Iba siya sa sequence. Okay, next is, ngayon, pag-usapan natin is, let's talk about the infimum or supremum or the lower bound and upper bound. Okay, so isa sa masisure ko sa inyo na yung set S, pag generate natin yan, ano ba yung magiging laman yan? So, ilagay ko lang ha. So, pag ito ginawa natin in Brewster form, this is 1 over 1, tama? Then 1 over square root of 2, 1 over square root of 3, 1 over square root of 4, then blah blah blah. Madami yan. Okay, as napapansin mo, as n approaches infinity, that is 1 over square root of infinity, that is 0. So, isa sa sure ko, yung ating set, siya ay bounded by 1, at the same time, bounded by 0. Okay, so isa sa sure ko, clearly, lagay ko nandito, clearly, 0 is a lower bound. Lower bound of S or per set S. Okay, so set ng pinag-uusapan ko muna, hindi pa sequence. So, baka isipin, sir, may lower bound ba? Yes, may mga lower bound, pero pag-usapan natin yung S kasi nga huhugutin natin yung mga infimum supremo. Okay, so sure ako na si 0 is a lower bound. Actually, marami yun. 0 pababa. Marami sila. So, maraming lower bound dyan, to be honest. Pero, syempre, target ko lang naman talaga mapalabas sa 0 eh. Okay, so what if sabihin ko na si 0 is lower bound? So, sure ako dyan, lower bound. So, also, it is not impossible. So, it is not possible, sorry. It is not difficult, I mean. So it is not difficult to show or to show that ano yung infimum na S, that the infimum of S is equal to 0. Sure ako dyan. Okay, what is the supremum? 1. Okay, yan yung mga sure na bagay natin dyan. So, let's talk about infimum kasi yun yung pupuntahan niya. So, clearly, 0 is a lower bound for S and it's not difficult to show that the infimum of S is equal to 0. Okay? So, another thing, yung sequence na ano natin. So, also, nung in-evaluate ko kasi yung set, pansin mo, palit siya. So, kung gagawin ko siyang sequence, palit din talaga yung value. Also, the sequence 1 over square root of n is a decreasing sequence. Okay? So, isa rin sa napansin ko, decreasing siya. Ikaw rin napapansin mo yan, sir, decreasing siya. Yes. Ngayon, alam ko rin na yung sequence na to is bounded. Okay, so saan siya bounded? Hindi ko siya pwede sabihin na bounded by 1. So, mas sure ako mas bounded siya by 0. Okay, so, also, the sequence 1 over square root of n is a decreasing sequence that is bounded. Lagi ko na lang. That is bounded by infimum of S, which is equal sa 0. Pwede tayo dyan. Okay? So, ngayon, ano ba kailangan natin para magamit yung monotone sequence? Monotone convergence sequence. Kailangan makapagpakita ka ng bounded, decreasing, or increasing sequence. So, kung siya ay bounded, decreasing sequence, then pwede kong gamitin yung conclusion ng ating monotone convergence theorem. So, kung nakita nyo, siya ay bounded, decreasing sequence. Okay? Since siya ay bounded, decreasing sequence, then, so, ayun yung purpose, bakit ko kinuha yung infimum of S? Then, so by MCT I mean, so by MCT or the monotone convergence theorem, the limit of 1 over the square root of n is equal to the infimum of S, which is equal sa 0. So therefore, this is done. Okay? So, ganoon lang ginagamit si monotone convergence theorem. So, kung gusto nyo, kung kaya mo siyang gawing set, kaya mong hanapin yung kanyang infimum or supremum, well, very useful to. So, at the same time, hindi ganito hindi sa lahat ng oras monotone ang sequence. Aware kayo dyan. Hindi sa lahat ng oras monotone ang isang sequence. Hindi dapat i-sure mo dyan. Hindi sa lahat ng oras increasing or decreasing siya. Okay, so dito lang kasi yung sequence na ibibigay ko is decreasing or increasing. Okay, so this is very useful para sa inyo. Okay, so let's talk about number 2. So, let y be the sequence of y sub n. So, be defined inductively. So, ibig sabihin inductively, parang y sub 1, y sub 2, y sub 3. So, inductively meaning, binigay ko yung y sub 1, binigay ko yung y sub n plus 1, binigay ko yung y sub n, binigay ko yung y sub 3. Kung binigay ko yung first term, binigay ko yung very last term, yung possible very last term niya, inductively. Okay, so, or parang recursively rin. Ganon din siya. Okay, so sabi nga, yung y sub 1 is defined to be, yung ano niya is defined to be, y sub 1 is defined to be 1, y sub n plus 1 is defined to be 1 over 4, 2y sub n plus 3. So, ayun ang given. Hindi mo alam mismo si y sub n. Okay, yan ang mismo given. Okay, so, letter A, show that y is bounded and monotone. So, ipoprove natin siya ng monotone and bounded. Letter B, find the limit of y. Okay, so start tayo dun sa pag-show na siya ay bounded and monotone. So, una, syempre, show ko dapat siya ay bounded. Tapos, at the same sunod is dapat siya ay monotone. So, paano ko ba masabi na siya ay bounded? Masasabi kong bounded siya pag siya ay bounded by a real number. So, let's say x. Okay, so dapat yun isa sa makita ko. Dapat bounded siya sa isang number. Okay, so ito yung proof. Ito yung for letter A. Ito yung ating proof. Okay, so isa sa sure ko, y sub 1 is equal to 1, y sub n plus 1 is equal to 1/4, 2y sub n is equal to 3. Okay, so by direct calculation, ano si y sub 2? Kasi ka lang pag gusto ko kunin si y sub 2, gagamitin ko yan. So by direct calculation, so dili ko dito, so by direct calculation, okay, y sub 2 is equal to 1/4 times 2 times y sub n. Ano y sub n dapat pag y sub 2? Y sub 1. So that is 2 times 1. Okay, then plus 3. Okay, and obviously this is equal sa 5/4. So by direct calculation, y sub 2 is equal to 5/4. Okay, so napansin mo, ito yan i-assume ko na siya ay decreasing sequence. So meaning, so y sub 1 siya ay malaki, sa increasing sequence siya, sa y sub 1 siya ay malaki, sa y sub 2 siya ay lalaki, increase konti, sa y sub 3 increase siya pero maliit na, sa y sub 4 i-increase siya pero mas maliit na kasi 1/4 yung pag-increase. Okay, kumbaga nung una, nung ako ay 1, nag-increase ako by 1/4, so naging 1 and 1/4 ako. So mag-i-increase ako by 1/4, another 1/4 nung 1/4 nun. So kunyari, nag-increase ako by 1/4, so yung 1 and 1/4, mag-i-increase pa ako by 1/4 something nun. Then plus 1/4 something ulit nun. Ganun kaikli yung pagliit niya. Okay? So, anong ibig sabihin, sir? Ako, isa sa magiging claim ko, isa sa magiging claim ko na this implies na si y sub 1, which is equal to 1, ay less than y sub 2. Kasi y sub 2 is 1 and 24. Tama? 1.25 I mean. Okay? So, isa sa isi-sure ko na lang or i-claim ko na lang that this is less than 2. So, what if hanggang less than 2 lang siya? So, ang pinakamalaking number na makukuha natin dyan is si 2. Okay? So, paano siya na-sure yun? So, for example, kinuha mo si y sub 3. So, kunyari, kunin mo si y sub 3, gagamitin mo si y sub 2. Makukuha mo si y sub 4, siyempre, gagamitin mo si y sub 3. Okay, so what if abutin mo kunyari ng y sub 1 million, tapos y sub 99 yung gagamitin mo, o y sub 999 something yung gagamitin mo, I think hindi pa rin siya aabot sa 2. Isa yun sa mga sure. So, i-calculate mo na lang bakit 2 yung nagamit na, sir. Okay, so ngayon ang claim natin, na kailangan natin i-show, so ang claim ko that y sub n is less than 2. Okay, so this is for n element of natural number. Okay, so ngayon, paano mo ipoprove ng isang sequence is less than 2? So sir, I think by induction, kasi n yung ano natin so at the same time inductively siya. Okay, so ang gagawin ko is skip ko yung verification, skip ko na yung for n is equal to 1, for n is equal to 2. Proceed na tayo by induction hypothesis, then by proof of induction. So that is what we call the strong induction. So pag in-skip mo sa verification, ang tawag doon is strong induction. So by strong induction, lagay ko na lang. So by strong induction, okay, so by strong induction, ang ano natin is if k is equal to ganito, so if y sub k is less than 2, called, okay, so for n is equal to k, then y sub k plus 1 must be true also. Ayun nangyari, kasi assume ko na n is equal to k, assumption yun, so true yun, then sunod na yung assume ko, dapat si y sub k plus 1, dapat true din yun. Okay, so ano yung y sub k plus 1? So consider natin yan. So y sub k plus 1 is equal to, so lagay ka lang y sub k plus 1 is equal to 1/4 times 2 times y sub k plus 3. Tama? Ayan, isolve natin yung part na yan. So, kung napapansin mo, may y sub k ako. That is less than 2. Okay, may y sub k by assumption, by induction hypothesis, that is y sub 2. So, this is less than, so napapansin mo, kung magpapalit ako dito, this is 1/4 times 2 times 2 plus 3. Ano ginawa, sir? Bakit naging less than? Okay, kasi naging less than, kasi anong nangyari, yung y sub k, pinalitan ko ng 2. So, meaning, mas lumaktong part na to. Okay, kasi yun yung assumption eh. Okay, since lumaki siya, this is equal to 1/4 times, that is 4 plus 3, that is 7. Okay, which is equal to 7/4. So, ang claim niya, si y sub k plus 1 is 7/4. So, ano ba yung 7/4 something na yan? Yung 7/4, check natin sa calculate. 7 divided by 4, piloso pong calculate, that's 1.75. So, imagine mo so y sub k plus 1 natin, 1.75 lang siya. Hindi pa rin umabot ng 2, which is less than 2. Okay? So, ano nangyari? So, si y sub k plus 1 is less than 2. Therefore, si y sub n is less than 2 for any n element na natural number. Therefore, y is bounded. Sir, bakit mo nasabing bounded? Kaya ako siya nasabing bounded kasi ang pinaka-possible na makakita nyo sa y sub k plus 1 na nakuha ko nga lang 7/4 or 1.75. Hindi ako umabot mismo sa 2. So masasabi ko bounded ako by some real number which is 2. So hindi ko pwede sabihin si 1.75. So mas sinecure ko na whole number kasi mas madali sa akin, mas madali yung computation o yung proof pag ganun. Okay, so note that y is bounded pa lang. So we need to show that y is increasing. So paano natin masabi siya ay increasing? So kung napansin mo, increasing ba siya? Yes sir, kasi nag-start tayo y sub 1 is 1, y sub 2 is 5/4, y sub 3 is something, y sub 4 is something, then y sub k plus 1 o yung 1 sub n plus 1 is 7/4. Ayun yung pinakamalaking makakuha niya. So pwede siyang bounded by real number na whole number. Okay, which is 2. So ngayon, ang gusto ko na napakita, so kung napapansin mo, increasing siya, dapat may pakita ko na yung y sub n, yung mga y sub n, y sub 1 is less than y sub 2, less than y sub 3, less than less than y sub k. Ganun dapat mapakita ko. Pero, I think mas better yung ganito. Okay, so note na by induction, ang nakita natin, si y sub k is less than y sub k plus 1. So, let us assume na ito yung ating assumption. Kasi true na yun by induction. Okay, napakita natin yan by induction. Okay, so by induction, ito yung nakita natin. Okay, so ang goal natin, nagpakita pa ako ng isa, di ba? Meron na ako y sub k. So, less than y sub k plus 1. So, ngayon, what if naman, kunin ko yung susunod kay y sub k plus 1. Ano sunod kay y sub k plus 1? Si y sub k plus 2. I think enough na yung tatlong bagay na yan. So, ang goal ko na lang, kuha ko ng y sub k plus 1 less than ba to sa y sub k plus 2. Okay, so ulitin ko lang. Ito yung assumption, ito yung if, premise, this is the conclusion. So gagalaw tayo, by sa theory, napapansin nyo dati, gumagalaw tayo sa conclusion, then ginagamit natin somewhere dun si assumption. Okay, so by means of this, so this implies that, gamitin natin to, in definition na yan. So y sub k plus 1, by definition, that is 1/4 tapos 2 times y sub k plus 3. This is less than 1/4. This is 2 y sub k plus 1 plus 3. Okay, kasi y sub k plus 2 na to eh. Okay, next. Divide both side by 1/4 or makakancel natin literal 1/4. Ang matitira lang, this implies that 2y sub k plus 3 is less than 2y sub k plus 1 plus 3. Okay, another obvious, makakancel si 3 kasi mag-subtract tayo both side ng negative 3. Okay, so this implies that 2y sub k is less than 2y sub k plus 1. And divide both side by 2 since non-zero siya. This implies that y sub k is less than y sub k plus 1. So, ano napansin mo? From conclusion, magagamit natin sa assumption. This is true. Kasi nga by induction. So, since this is true, therefore, si y sub k plus 1 is totally less than y sub k plus 2. Okay? Now, therefore, ano man sabi nyo? Therefore, ulit, for all n natin, so yung y sub n plus 1 natin, so yung y sub n is less than y sub n plus 1. So, for all n element ng natural number. So, pansin mo, y sub k less than y sub k plus 1, less than y sub k plus 2, less than y sub k plus 3. This is true. So, this implies that y is increasing or a monotone. Okay? Y is bounded, y is increasing. So, therefore, nakuha natin yung ating goal. So, therefore, this is done. So, ganyan siya i-prove. Ganyan siya medyo kahaba. Okay, so start naman tayo dun sa letter B. Ano yung sabi ng letter B? Find the limit of y. Okay, so paano hanapin yung limit of y? Okay, so since hindi siya proving, hindi natin siya ipoprove. Ang kailangan natin gawin, hanapin lang natin yung limit of y. Okay, so kung napansin mo, since alam ko siya ay sequence, alam ko siya ay bounded, alam ko siya ay bounded at the same time alam ko siya ay monotone. So by monotone convergence theorem, alam ko convergent siya. So may sequence na may tawag dito, may limit na lalabas siya. So let us assume na yung limit muna ng y sub n natin. So ito muna, let yung limit ng y sub n ko is equal to x. I-assume ko muna ng limit ng y sub. Okay? So ngayon, ito yung totoo. Pag yung limit ng y sub n is equal to x, yung limit ng y sub n plus 1, x din yun. Yun dapat masigurado nyo, ha? So, kasi nga increasing lang din siya eh. So, increasing siya, induct ko siya na induct. Same pa rin ang limit lahat yun. Kahit gaano pa kataas, kahit gaano pa kalayo yung peak na napupuntahan ko. Okay? So, aware tayo, yung y sub n plus 1 is equal to ganito. So, note na yung y sub n plus 1 is equal to 1/4, tapos 1/4, that is 2y sub n plus 3. Next, applying the limit both side, ano mangyayari? So pag in-apply ko yung limit dito, this is limit nung y sub n plus 1, okay, equal to sa 1/4, lalabas ko na yan. Then this is limit ng 2y sub n plus 3. Okay? So, apply natin yun, nilet natin. Sabi, let limit ng y sub n is equal to x. So, therefore, itong limit ng y sub n plus 1, x din yan. Kasi nga sabi ko, similar. So, this is x is equal to 1/4 times, ito ay magiging 2x plus 3. Kasi limit ng y sub n is x pa rin. Okay? Then, by computation, this is 4x is equal sa 2x plus 3, which mean that 2x is equal to 3. Tama? Therefore, what is x? So, this implies that x is equal to 3/2. By the way, what is x? X is the limit of y sub n. So, what is the limit of y sub n? The limit of y sub n is equal to 3/2. Okay, so therefore, this is the limit. Okay, so napaka-dali lang niya. So, ganito lagi gagawin pag pinahanap ko naman yung limit. Okay, so let's talk about number 3. So, let Z be the sequence of C sub n, be the sequence of real numbers defined by C sub 1 is equal to 1, C sub n plus 1 is equal to square root ng 2C sub n. Find the limit of Z. So, similar thing, yan na din yung ginamit ko kanina. So, let ko naman dito, na yung kanyang limit is equal to x na lang din. Okay, so since hindi siya proving, hindi naman natin kailangan i-require i-prove. So, let natin dito. Let na doble. Again, let limit ng C sub n is equal to x na lang. Okay, so we have C sub n plus 1 is equal to square root ng 2C sub n. Applying the limit both sides, this is equal to limit nung C sub n plus 1 is equal to limit nung square root ng 2C sub n. Okay, so after applying the limit, obviously this is x. Okay, and this is square root of 2x. Yun is sure ko. Okay, so next is anong gagawin natin dyan? Square natin both side, that is x squared, which is equal sa 2x. Okay, then divide both side by x. Therefore, x is equal to 2. So, ano yung limit? Therefore, the limit of c sub n is equal to 2. And this is the answer. Okay, so napakadali niya talaga. Okay, so before ko tapusin yung video, let's talk about the Euler's number. So, dito din talaga na form. So, yung mga irrational number na alam nyo, si pi, si Euler, dito talaga nanggaling sa sequence yan. So, sir, bakit? Sa sequence kasi, nakapag-form sila ng sequence into which nagtetend siya sa isang number in which hindi naman nila kayang gawing rational number. Okay, so tulad ni pi, so gumawa sila ng sequence. Ganito ginagawa ng mga mathematician ngayon para ma-discover nila. So gumagawa talaga sila ng sequence. Ito yung ginagawa nila para matapos nila yung pi. Gumagawa sila ng sequence into which na nagtetend siya. Yung mga term niya is nagpupunta sa pi, dun sa mga term ng pi. Pero ang goal nila dapat yung term ng pi na yun. So as n approaches infinity, as n becomes larger. So sabi nga nila nasa 1 billion something na yung C sub kunyari pi sub n, so pi sub 1 million na something yung kino-compute ng mga supercomputer So ito yung isa sa mga sabi nila. So ngayon, ano nangyari? It turns out na hindi pa rin niya makompute literal na okay, ano ba yung sunod? Ano ba to? Parami pa siya. Hindi pa rin talaga siya tumitigil. So hindi nila talaga nakikita literal yung pinaka-bound o yung pinaka-bounded, yung pinaka-upper bound ng pi na yon, yung dulo. So ngayon, ito si pi. So ICE, I mean. So Euler's number naman, ito si E. So nasabi ko rin to. So mas familiar kayo dito dahil kay calculus. Okay. So si Euler's number, which is represented by E, ay na-discover by kay Leonard Euler. So Euler or Euler depende sa basa nyo. Okay, so hindi ko kasi sure So may isang prof sa akin dati nagturo, ang basa is Euler. May narinig naman basa is Euler. So I don't know kung ano yung tamang basa. Pero for the meantime siguro mag Euler or Euler na lang tayo. Okay, so yung Euler number na E, that is discovered by Leonard Euler. So sabi mo sir, dapat siya ay sequence. So ito yung sequence talaga ni yung E na yan. Okay, so rate ko lang ano yung sequence na E na yan. Yung sequence na E na yan, ito yung alam nyo dyan, no? So yung E is approximately, sa calcu, tinignan ko lang, that is 2.71828284845 laki ng calcu ko, no? 045 dot something. Madami pa yan, hindi yan tatapos until now. Okay, ngayon yung kanyang sequence, ito yun ito yung E sub n is equal to 1 plus 1 over n raised to n. Ayun yung kanyang sequence. So ngayon, ang sabi ni sir, yung sequence na yan is magtetend sa E as n approaches infinity. Yung Euler's number na yan. Ngayon sir, dapat mapatunayan natin na yung limit niya is E. Okay, so let us check na dapat yung limit niya is E. So, kunin natin limit ng sequence na E sub n, which is equal sa limit ng 1 plus 1 over n raised to n. Okay, so yan, di natin kaya kunin calculus. So wala tayong kayang gawin para makuha yung limit niyan. Okay, so actually by ano na lang yan kumbaga maglalagay lang tayo lagi ng kunyari for n is equal to 1. So let for n is equal to 1, that is 1 plus 1 raised to 1, that is 2. For n is equal to 2, that is 1 plus 1 half raised to n. So raised to 2, that is something 3 over 2 raised to 2. Then for 1 plus 1 plus 1 over 3 raised to 3. Then 1 plus 1 over 4 raised to 4. Ganun yung gagawin yan, tuloy-tuloy Okay, so it turns out na may kita mo. So ako hindi ko napapakita, tuloy-tuloy lang May kita mo na lang dyan, isa-sure ko. Isa ang makikita mo is yung limit is approaches to E or 2.7 something. Ayun yung mangyari. Ulit ka lang, kunin mo yung limit yan. So palakihin mo lang lagi sa n. Mapapansin mo, hindi siya lalagpas or mag-i-exit kay 2.178. Ganyan karami na yan. Okay, so ulit ko lang, si Euler's number, siya ay dating sequence din. Actually, sequence pa rin siya until now. So, may sequence talaga na nagpupunta sa kanya. So, ito yung example ng sequence na nagtetend sa irrational. Okay, so somewhere natin dito sa mga discussion natin sa mga susunod pa, magpapahanap ako ng sequence na dapat nagtetend sa rational, sequence na magtetend sa irrational. So parang ganito, hahanap ka ng sequence ng real number na magtetend sa irrational. Hahanap ka ng sequence ng real number na magtetend sa irrational. Ayun yung mga sunod natin na gagawin. Okay, so this is all about the video. Ayoko na siyang i-discuss pa. Actually, meron siyang way para masabing bounded. So another thing, bounded siya. Saan siya bounded? Bounded siya by yung mga upper bound na yan. Okay? What I mean lang pala kanina is hindi talaga siya totally bounded siya by E. I mean, yun is sure ko. Bounded siya by E, pero hindi kayang compute yung sequence na yun, yung exact value ni E. Okay, ito yung sequence na to, siya yung sequence na kung saan magtetend siya kay E. Okay, meron talagang computation pa kay E na kung saan hindi pa nila makukuha to until now. Ayun pala isa sa mali na nasabi ko kanina. Okay, so hoping na papanoorin pa yung next video kasi nga medyo importante rin to.